Okay, yesterday we learned how to graph a sine function and all the transformations that we can do with the sine, how we can move it up and down with the vertical shift, and how we can stretch it vertically with the amplitude. Today we're going to be doing the exact same thing for a cosine function. So you've got all these spaces on the page there for a cosine function, and if you just want to write C sine page, because all of these characteristics are exactly the same. So for a sine graph, we said period means the length of a cycle. It's always 2 pi. It's the exact same thing for cosine. From beginning to end of our cosine graph, even though it's a slightly different pattern, slightly different curve, it is still going to take us 2 pi units to complete one cycle, or one period. It is a periodic function, so it does continue forever in both directions, repeating that same pattern over and over again. So its domain is still going to be all real numbers, or negative infinity to positive infinity. And unless there's been some kind of amplitude change or shifting up or down, the range will be from -1 to +1. The amplitude is still the distance from your midline up to your maximum or down to your minimum. It's always going to be the absolute value base. Amplitude will never be negative. And vertical shift is how much you move that midline up or down. So it takes that whole graph and shifts it up or down. So exact same things that we had from yesterday. Just like yesterday where we said a times sine of x plus b, and we identified things, we're going to do the same thing with cosine. All right, just like with our cosine function, just like with our sine function, a in our cosine function does stand for amplitude, and b does tell us our vertical shift. So a lot of the things here are going to be very similar. We're still going to have the same period length. We're still going to identify amplitude and period first. We're still going to have the same, and I should say for math 3, our x values will still be the same, the 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is the part that's different for cosine, the corresponding y values. In a cosine graph, in a sine graph, start, middle, and end are the same, but look at your start, your middle, and your end. They are not the same. Start and end are the same, and they're up at the maximum. Middle is the exact opposite. It's at the minimum. Now, remember how sine sometimes started going up and sometimes it started going down. The same kind of thing happens with cosine. If our leading coefficient is negative, amplitude we still call it positive, but that would mean our graph would start at the middle and the minimum, go to the maximum, and end at the minimum. And then here's your midline. Notice your other two remaining points will be on that midline. So in sine, start, middle, and end are on the midline. On cosine, it's the other 2 points. They're the midline, and start, middle, and end give us our maximums and minimums. And then we're still going to connect them with a smooth curve. We're still going to show arrows to show that the graph continues forever in both directions. All right, just like yesterday, I'm going to do some examples and then give you a chance to do some on your own. I'll do 3 and give you a chance to do 3. All right, so on this first one, amplitude is 2. Period is always 2 pi. We never have phase shift. Vertical shift, there isn't anything added here, so there is none. Always start by drawing your midline. All right, same x values that we had yesterday. All right. Everything we've done so far, absolutely no different than it was for sine. What is different is now our points here. So this is a positive graph, so the start and end are going to be at the maximum. If it was negative, they would be at our minimum. These points are the ones that are on the midline. So let's fill in our middle points here, and they are on the midline. The midline hasn't shifted up or down, so it's at 0. To get to our maximum, we're going to go our amplitude's distance above this midline. So we're at 0, and we're going to go up 2 units. and then our middle point here is going to be the minimum. So we're at 0 on the midline, and we're going to go down 2 units to get to the minimum. And let's plot these 5 points. 0, 2, pi over 2, 0, pi, negative 2, 3 pi over 2, 0, and 2 pi, 2. And then I will connect points and draw in the arrow. So it's very similar to sine, except where sine goes up, hits the middle, goes back down, and ends on the middle. This starts and ends at the top, and you've got that section where it goes down in the middle. All right, what about this one? Cosine of x plus 1. Nothing in front listed for our amplitude, so it's an understood 1. Period's always 2 pi. No phase shift. Vertical shift, up 1. Here's our critical points. Amplitude, vertical shift tells me my graph's midline moves up 1. And again, nothing we've done so far is any different than what we did for sine. Now let's do something different. Is this graph going to start at its maximum or start at its minimum? Well, it's positive, so it's going to start at its maximum. And its start and end are the same. The middle does the opposite. So we're starting and ending at the max. Here's going to be our minimum. And these 2 points will be on the midline. So the midline's up 1, so it's at positive 1. And I can go ahead and plot those points if I want to. All right, our maximum is going to be 1 unit above the midline. So the midline's at 1. 1 above 1 is 2. And our minimum is going to be amplitude's distance of 1 below the midline. So midline's at 1. 1 below 1 is 0. Smooth curve. And arrows. All right, amplitude, absolute value of A, positive 2. Be careful, amplitude's never negative. This just tells me my graph, instead of starting up at the top, starting at my maximums, my graph's going to start at my minimum. So it'll end at the minimum, and the middle point will be our maximum. Period, still 2 pi, no phase shift, and this time, again, no vertical shift. List out those critical points. And now let's draw in our midline. It hasn't shifted up or down, so it's still the x-axis. All right, our minimum that we're going to begin with, and first of all, let's plot these 2 points. They're going to be on our midline, which is at, didn't go up or down, so it's at 0. Our minimum is going to be 2 units below that, down here at negative 2. And our maximum is going to be 2 units above our midline here at positive 2. Connect the points in a smooth curve with arrows. Amplitude is 3 on this one. I'm going to get you started on this one and give you a chance to finish it. Period, always 2 pi. No phase shift. And this one also has no vertical shift. So midlines here. Same x values as always. All right, so see if you can fill in what would be your y values and plot your points. All right, this graph was positive, so it starts at its maximum. Its maximum is 3 units above, 3 because of the amplitude, units above the midline of 0, so its maximum was 3. And its minimum is 3 units below the midline of 0, so it's down here at negative 3. Smooth curve and arrows. All right, try this one. 3 times the cosine of x minus 1. List everything and graph it. All right, you can see our amplitude of 2. vertical shift down 1, how that affected our graph. Check your points. It still is starting at the top, and we've got the smooth curve and the connected points with the arrows. All right, last one. If you will, pause the video and try all parts of this graph. All right, so our last graph experienced everything we've talked about. It started at its minimum instead of its maximum because it's negative. Amplitude of 4, so it has a vertical stretch, and a vertical shift going up 2 units. So I shifted my graph. I found my minimum to be -2, my maximum to be 6. And that would be a good test question would be if I asked, on this particular graph, what is its maximum point? Well, it's shifted up 2, and then it goes 4 above that, so 6. Or its minimum point, it's shifted up 2, and it goes as far as 4 below that. So you have 4 of these cosine questions for homework, and you can work on that at this point.